Hello learners, and welcome to today's lesson of finding the equation of functions. Let's look at what we are going to be focusing on today. So looking at our concept map here, we are going to be focusing on the straight line function, the parabolic function, the hyperbolic function, and the exponential function. So we are going to be focusing on those functions and how we can find those equations. So now by the end of the lesson, we will address the standard form of each function and the characteristics needed to find the equation of each function. Now, looking at the keywords that we are going to be using during this lesson, and of course, these are words that you are also familiar with, and that is function, the x-intercept, the y-intercept, turning point, maximum, minimum, asymptotes, domain, range, and excess of symmetry. So those are words that you are familiar with using, of course. Now let's look at those common errors or those misconceptions that you should be careful of while you are working with when we are finding the equation of a function. That is, learners do not know the standard forms as well as the general shape of each function. Learners do not know how to interpret the properties shown on a sketch into the standard form of an equation. And the last one there, learners do not know how to interpret characteristics into a standard form of an equation. So of course, those are things that you should be careful of when you are working with finding the equation of a function. Then we are looking at certain skills that you will need so that you can have a better performance in that examination. So those are the skills that you should be focusing on when writing your exams. Now, let's look at what you should know or be able to do from the lower grades, which is grade 10 and grade 11. Well, you should know how to find the gradient between 2 points. You should also know that parallel lines have the same gradient. Perpendicular lines have gradients that result in a -1 when multiplied. That is the gradient of one line multiplied by the gradient of another line. They should give you -1 if they are perpendicular. Then also substituting given points into a standard form of an equation, solving for two unknowns simultaneously, and of course, interpreting the domain and range of a function. So those are the things that you should know from your lower grades. Let's quickly go to an ad break, and then we'll see you just now for the rest of our lesson. Welcome back from the ad break, and let's continue with our lesson. So we are going to firstly focus on the straight line function. Now, the content and skills problems is that learners cannot interpret given information from a sketch to a formula. And of course, learners confuse the relationship between the gradients of perpendicular lines and parallel lines. Now, when it comes to the exam, learners do not thoroughly know the characteristics of functions. Learners do not spend enough time examining the given information before attempting to answer the question. And also, learners do not associate the given information with what they already know. So those are the things that you should be careful of when writing an exam. Let's look at the key theory aspects that you should have from grade 10 right up until grade 12 that you have previously learned. An increasing straight line function has a positive gradient. A decreasing straight line function has a negative gradient. To find the equation of a straight line, we need the gradient and the y-intercept. The standard form used to find the equation of a straight line is either y is equals to mx plus c or y minus y1 is equals to m multiplied by x minus x1. The relationship of the gradients of two perpendicular lines is the gradient of one line multiplied by the gradient of another line is equals to -1. And the gradients of two parallel lines are equal. So let's go on and look at our questions. Now, the first question there says, determine the coordinates of D if D is the image of B after B is translated 2 units to the right. So we are being told that it is the image of B, and so which means that it is going to share something with B. Now looking at B, B has the coordinates of 3 and 0. So 3 and 0, that we know that the x value is 3 and the y value is 0. And since as well B and D are both on the x-axis, it actually means that we already know that the y value of the D coordinate is going to be 0 there. So when it comes to the coordinates of D, we know that our y value is going to be is going to be 0. And then when it comes to the x value, we've been told that B is translated 2 units to the right, which means that we are going to be moving from this 3 and we are going to move 2 units for us to get to that D, which means that the value there is going to be 5, because when we move from 3 2 units to the right, then we are at a value of 5. So that is the coordinates of D. Let's look at the next question there. It says, determine the equation of G. Now, as we can see, G is our straight line, and just like we've discussed previously, when it comes to the straight line, we need 2 points, and we already do have those 2 points. But now remember, when it comes to the value of C, now remember the standard form of a straight line is mx plus c. But when it comes to that value of C, that is also the y-intercept. And since as well, we already have the y-intercept there given to us, there it has a value of 3, it means that we can write down our standard form as mx plus 3, because we already have that value of 3 there, which means now we just need to find the gradient. So how can we find the gradient? Well, since as well we have another point on our straight line, we can then substitute we can either calculate the gradient or we can substitute the value of x and y. So as we can see there, we have calculated our gradient using those 2 given points. And since as well we have our gradient as negative 3/5, we then know that our gradient is negative 3/5. Our value of C is a positive 3. We substitute it into our formula, and that is the formula for G. Now, let's go and look at the next question, where we are going to find the equation of our graph. Now, remember, in the equation that we were not given values, but it was given in standard form. So let's go now and determine the values of A, B, and C in our equation of F. Now, remember, we had been given the x-intercept, so we are going to use those x-intercepts to find the values of A, B, and C. So substituting it into our x-intercept form, we can see there that we have A, open bracket, x plus 1, close bracket, and in the next bracket we have x minus 3. Now, for us to find the value of A, we need to find another point that is on the graph that we are going to substitute, and we are going to find now that value of A. The only point that we can use is point C. Take note that we cannot use point D because point D is not on the parabola. So we are going to substitute the values of x and y using point C. That is 0 for the x value and 3 for the y value. And of course, if we work that out, we can see that our our A value, the value of A, is negative 1. Now remember, it's not only the value of A, we need to find the value of B and C as well. So we are going to use those x-intercepts again, except this time we do know what the value of A is, and that is a negative 1, as you can see substituted there into our graph. Then that will give us an equation of negative x squared plus 2x plus 3, which means that A, of course, we had calculated as negative 1, B is equals to 2, and C is equals to a positive 3. Let's look at the last question there, which is determine the coordinates of E. Now, when we are looking at E, we can see that that is a point of intersection. It was also given to us in our information. But what happens at a point of intersection? It means that those two functions there are going to be equal, which means that we are going to take the equation of the straight line and the equation of the parabola. So the equation of a straight line there is a negative 3 over 5x plus a 3. So that is a mistake there. That is equal plus a 3. Remember, the y-intercept there is a 3. So when we are going to combine the like terms or bring actually everything over to one side, we then have x squared minus 13 over 5x, and that is equals to 0. We are then going to factorize that equation there. That is going to give us x open bracket x minus 13 over 5 close bracket, and of course we are going to get the two x values of x is equals to 0 or x is equals to 13 over 5. And of course you did have to get two values there, because when we look at our graph, it does intersect at two values at that point there, which is on the y-axis where x is equals to 0, and of course the other point there, which is point E, where the other x value there will be 13 over 5. So we know that at E, the x value is 13 over 5. We calculate the y value by taking the x value and substituting it into our original equation. Now, which equation can you use? You can either use the equation of G or the equation of F. It does not matter, because E is on both the equation of is on both the straight line and the parabola. So whichever one you decide to use, you are going to get an answer where the y value is 36 over 25. And of course that means that the coordinates of E is 13 over 5 for the x value and 36 over 25. So 36 over 25, let's just do that, 36 over 25, and that is for our coordinates of E. Let's quickly go to an ad break and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson. So now we are going to be moving on to the next function, and that is the hyperbolic function. Let's look at the problem when it comes to the hyperbolic function. So firstly, learners struggle to interpret the information given in a sketch to an equation, and also learners do not understand the concept of asymptotes. And when it comes to the exams, learners confuse or forget the types of functions if the formula is represented in a format that they are not used to. So let's look at how we can resolve that. Firstly, we are going to look at the key theory aspects there. A positive hyperbola is found in the first and the third quadrant. A negative hyperbola is in the second and fourth quadrant. And the standard form of a hyperbola is y is equals to a over x plus or minus p, also a plus or minus a q, where x minus p is equals to 0 and y is equals to q are the vertical and horizontal asymptotes. So let's look at an example there. It says there, the diagram below represents the graph of f of x is equals to a over x minus p plus q. T, which is 5 and 3, is a point on f. Now determine the values of a, p, and q. So of course here we are just being asked to determine the equation of this given hyperbola. So remember, we are going to just spend time on looking at what we have been given here before we can attempt the question. And again, we are going to answer the question by substituting the values that are given in the formula. So looking at the diagram there, we know that P and Q are the ones that represent our asymptotes. So automatically we can see that the vertical asymptote is passing where the x value is equals to 4, and we can see that the horizontal asymptote is passing where the y value is equals to a positive 2. And of course we have one point that is given there, and we know that we are going to need to use that point for us to find the value of a. So seeing that the asymptotes that are given are 4 and 2, we then know that our p is equals to 4 and our q is equals to a 2. Then when we use the equation that we have been given to substitute these values, there we have it. We've substituted our value of p and our value of q. Now, when it comes to this substitution, it is very important, because now the common mistake that is done here is that because our value of p was positive, now when you put it back into the formula, you still make it positive, or you would say there that x plus 4. But this is something that you really need to be careful of. It is going to be x minus 4. What we can use, or what you can use to remind yourself, is to look at what you have been given there. So you have been given that x minus a p at the bottom. We know that if we equate it to 0 there, that is going to be x is equals to p, right? So in this case, we know that our x that we found in our asymptote is equals to 4. But now when we need to take it into the equation, we need to take our 4 and bring it back to the same side with our x, and that is going to be x minus 4, and that's going to be equals to 0. So can you see how that positive 4, when it goes now back into the equation, it is going to be a negative 4, and that's why we've written there a negative 4. And of course, we are going to substitute that given point of 5 and 3. The 5 is the value of x, that's why we've substituted into the value of x, and y is 3, that's why we've substituted 3 there into the value of y. This is going to allow us to get the value of a. 5 minus 4 is of course 1, so a divided by 1 is a. We still have that plus 2. And when we take 2 to the other side, that is going to be a 3 minus 2, which is going to give us a 1. And of course, that means that the value of a there is going to be 1. So that is us now finding the values of a, which is 1, of p, which is 4, and of q, which is a 2. Let's move over to the next concept of our concept map, and that is the exponential function. Let's look at the first example of the exponential function. It says there, the sketch represents the graph given by f of x is equals to a exponent x. Now remember, whatever question you are going to be asked, you need to substitute what you know of that function. It doesn't matter how funny it may look, how weird it may look, you need to just substitute and trust that you will get to the correct answer. Let's look at the first question there. It says, write down the coordinates of A. Now, as we are looking at A, we can see that A is on the y-axis. So definitely, we do know something about the coordinates of A, and that is our x value. So our x value there is our 0. So when we are going to find the y value of the coordinates of A, we need to use the given equation. Now, the given equation there is y is equals to A exponent x. Now, when it comes to this question, what mainly you might struggle with is that you do not know the value of A. But in this case, you do not need to know the value of A. Let's just substitute and see what I'm talking about. So this is y is equals to A exponent x. We are going to say the only thing we do know about this coordinate of A, or what we can substitute here, is of course that value of x, and we do know that the value of x there is a 0. Now, going back to those exponential laws, what do you know about anything that is raised to an exponent of 0? Yes, it will be 1. So do you see how you did not need to know the value of A there? Because whatever value of A is, when we raise it to an exponent of 0, the answer is going to be 1. So what is the coordinate of A? It means that A is 0 and 1. And we found that value simply by substituting. The next question here says, determine the value of A if B is 0.3 and 1/27. Now, we need to substitute what we have been given. So initially, the point of B was not given, but now it is given. And of course, we are going to need it for us to calculate that value of A. Now, remember that the equation that we were given was f of x is equals to a exponent x. And all we need to do is just to substitute the value of x and y. Of course, we know that our x value is 3 and our y value is 1/27. So there we've substituted our two values. Now, whenever we have a case like this, we try then to get the both sides of the equal sign to the same base. And of course, if you know your exponent laws and if you know your factors, you would know that we can get them to either the same base or the same exponent so that we can find that value of A. So as we know that 27 can be written as 3 cubed. So there we have it as 1/3 cubed. And this is where you need to remember those exponential laws. Because now, when we go to the next step, that 1/3 cubed can now be written as 3 to the exponent -1, and we have our exponent 3 with that. Now remember, that comes from us saying 3 to the exponent of -3, which is of course equals to a cubed. But then now, because we want these two to have the same exponent, we are just going to write it in that form where we have 3, -1, close bracket, and then exponent 3. But you know, using your exponent laws, if you multiply those two exponents, it will still take you back to the same answer. And now, because these two have the same exponent, which means that the bases are equal, which would then mean that 3 to the exponent of -1 is equals to a, which means that the value of a is 1/3. And that is how we have calculated or found the equations of this function. It means that if we were to write out this equation in full, it would be f of x is equals to 1/3, and that is to the exponent of x, because now we know what the value of a is. That was a wonderful lesson, and I hope you enjoyed it just like I did. Hope to see you next time. Goodbye. Hello learners, and welcome to today's lesson of finding the equation of functions, where today we are going to focus on those practice questions. Let's go to our first question. The first question there says, the graph of g of x is equals to a exponent x is drawn in the sketch below. The point S, which is 2 and 9, lies on G. T is the y-intercept of G. So T is the y-intercept of G. So let's see what our questions are. But before we can look at the questions, you need to look at the diagram that has been given, connected to the information that has been stated on us. So let's look at these exponential. So of course we know it's an exponential because of the form of the equation that has been given to us. We can see that x is in the exponent, making this an exponential graph. Now, is it an increasing exponential or a decreasing exponential? Of course, this is an increasing exponential. Why do we say that? Because we can see that from the left going to the right, when we move along our graph, the y values are increasing, which means that this is an increasing exponential. Now, when it comes to an increasing exponential, what value of a would we be expecting? Because if you are going to be asked to calculate that value of a, you need to know whether you would be expecting an answer that is greater than 1 or an answer that is between 0 and 1. And in this case, because it is increasing, we are of course expecting an answer that is greater than 1. This will help you during the exam to know if you are correct or not. Let's look at what the questions are asking. So now the first question there says, write down the coordinates of t. Now let's look at where t is. Now we can see that t is the y-intercept. Of course, this was also given in our information. And us knowing that t is the y-intercept, we already know the value of one of the values there, and that is the value of x. So we already know that x is equals to 0. What about the y value? Well, we are going to go and we are going to calculate that. Of course, we are going to use our equation that we were given, and that is y is equals to a exponent x. Now when we substitute the value of x there, we can see that y is equals to 1, which would mean that the coordinates of t there are of course 0 and 1. Then we go over to the next question there. It says calculate the value of a. Now, where is the value of a? The value of a is found there in the given equation. So we can see that our equation is not complete because of those unknown values. So the value of a there is, of course, the one that we need to calculate. But what are we going to use to calculate the value of a? We are going to go back to the sketch that has been given to us, and we are going to look for what we can substitute into that equation for us to find the value of a. So looking at the equation there, of course, it is y is equals to a exponent x. Now we have been given another point, and that is the point of s. Now the point of s has, of course, an x value and a y value, and we are going to use those two values to substitute into our equation. Now the value of y there is 9, and the value of x there is our 2. So that is what we have after we have substituted there. So now, because we are working with exponents, you need to think of your exponential laws. We are going to write our 9 as 3 squared. And of course, on the other side, we have a exponent 2, which is a squared. Now, because the exponents are equal, we are going to say that the bases are also equal, because we can see that these two powers are equal to each other. So because they have the same exponent, it means that the bases are equal as well. So therefore, that means that our a is equals to 3. And there we have it, the value of a. Then it says that the graph of h is obtained by reflecting g in the y-axis. Write down the equation of g. Now remember, we've just calculated the value of a. It means that from that question moving forward, when we are working with the equation of g of x, we are going to write 3 exponent x. We are no longer working with a exponent x because we have calculated that value of a. Now, we are told that there is a graph of h. So this is a new graph that is being introduced, but it is found by reflecting the given graph of g, or the calculated graph of g rather. It is obtained by reflecting g on the y-axis. Now, when we are thinking of reflections, we are thinking what value changes when there is a reflection on the y-axis. Of course, you should know that reflecting on the y-axis means that the value that's going to change is the x value. So we are going to use this equation that we already have, which is 3 exponent x. But now, because we are reflecting, it means that the graph of h, rather, let's write it like this. It means that the graph of h, it means it's going to be 3 to the exponent of negative x. Of course, that would be the equation of h of x. You can leave it like that, or you can use your exponential laws and write it as 1 over 3. And of course, this is going to be an exponent x. So that is the equation of h. Let's quickly go to an ad break, and then we'll see you just now. Welcome back from the ad break, and let's continue with our questions. So now we are going to go on to that third question, and it says, the graph of g of x is a, open bracket, 1 over 3, close bracket, exponent x plus 7. And it passes through the point E, which is negative 2 and 10. And our first question there says, calculate the value of A. Now, firstly, we need to decide what kind of function this is. And of course, this is an exponential function, and we see that because of the exponent x. So we are going to calculate the value of A, and we can simply do this by just substituting. So we are given the equation, which is y is equals to, and that is A open bracket 1 over 3 x plus 7. So we are given another point that we can use to substitute into this equation, and that's going to allow us to find the value of A. So we are going to just substitute the point that is given, and that is 10 for the value of y, and then for the value of x, of course, that's going to be a negative 2. And this is where your exponent laws need to come into play. Of course, you can use your calculator as well, just for that 1 over 3 to the exponent of negative 2. So we are going to calculate that 1 over 3 to the exponent of 2. That, of course, is going to give us a 9 multiplied by that A, because our power is still multiplied to that A. So you need to make sure that they remain together. And of course, we have the plus 7 on this side as well. Then we are going to have 9A is equals to, and on the other side, we are simply going to have 10 minus 7, which is going to be a 3. Now, because we are looking for the value of A, we're going to divide both sides by 9. That is going to give us 3 divided by 9. And on this side, we have A. And of course, the value of A there is going to be 1/3. And that is going to be the calculated value of A. Let's go over to the next question. Well, it says there, calculate the coordinates of the y-intercept of G. Now, remember, the y-intercept is where we know that x is equals to 0. And also notice how with this question, no sketch was provided. So all we needed, or all we had to determine from our given equation is the value of A, which we didn't need a sketch for us to calculate. We had a point, we just substituted everything that we were given, and that's how we calculated. Same with this next question. It is asking us for the y-intercept. We do not need a sketch to calculate these values. We can just use the information that we know. So a y-intercept, we know that x is equals to 0. So let's go ahead and calculate that y-intercept. So we are going to use here y is equals to, and remember, we now know what the value of A is. So do not continue using A because you've already calculated A. So we are going to say 1/3, and this is multiplied by 1/3 to the exponent of x. And then we add our 7. Now we know that x is equals to 0, so that's going to be 1/3 multiplied by 1/3 to the exponent of 0 plus 7. Now, be careful here. When it comes to exponent laws, anything to the exponent of 0 is 1. And here, the only thing that becomes 1 is that 1/3 that is in the brackets. So that means we still have here 1/3, and this is multiplied by 1 because it was to the exponent of 0. So the only thing that changes there is that. So you need to be careful of that. So then you are going to place everything on your calculator. And what is our answer for the value of y? The value of y there is going to be 22/3. 22/3, which would then mean that the coordinates, because the question did ask for the coordinates, remember to always go back and read what the question is asking for. So it means that the coordinates of our y-intercept is going to be, we already have 0 for the value of x, and for the value of y, we have 22/3. Let's move over to the next question. Now the next question there says, consider g of x is equals to a over x plus p plus q. Now again, no sketch is provided, so we need to take the information that we've been given and also look at the standard form and see what type of graph it is. Now as we can see, our x is in the denominator, which means that this is a hyperbola. And as we know, a hyperbola has asymptotes, right? Now, it says there the following information of G is given. It says there that the domain is x is an element of R, but x cannot be -2, which means that this hyperbola can be all the values of x except for -2. Do you know what that means? Yes, of course, that means that our asymptotes, or one of our asymptotes, is that x is equals to a -2. The fact that x cannot be -2, it means that's our asymptote. And of course, we can already substitute that into our equation. Then we've been given an x-intercept of k, which is 1 and 0, and a y-intercept of n, which is 0 and -1. So the first question there says, show that the equation of G is given by. So we have been given an equation. Now, when it comes to these questions that ask us to show that an equation is a certain equation, you need to make sure that you do not use the information that has been given. So this is the result that we are supposed to get in the end, right? So we need to make sure that we do not use what we have been given here. So let's now use what we were originally given to find these values that we are expected to have at the end. So now at least we know what the answer is going to be, but we need to find those values given with the given information. So as we said that from the information we know that the asymptote is x minus 2. Now when we are going to, or is x is equals to -2, when we are going to substitute that back into our formula, you remember we need to take now the -2 back to the same side with the x, and that's going to be a x plus 2. So we know that in our formula, that's what we are going to substitute. So we have there an x is equal, a y is equals to, and we have a over, and that is x plus 2 and plus q. Now, what are we going to substitute for us to be able to find the missing values or the unknown values? We are going to first substitute the given points that we have been given. So we know that x there is 1 and y is 0, and that's exactly what we are going to substitute. And after we've substituted those values there, we have 0 is equals to a over 3. Plus q, sorry. Now, we can see that here we have two unknowns, which is a and a q. And whenever we have two unknowns, we need a second equation so that we can solve for these values simultaneously. We can start by simplifying this first equation there, and because we don't want to work with fractions, although in some cases you do have to, but in this case we can simplify it by multiplying each number by 3. Remember, if we want to get rid of a denominator, we just multiply by that denominator. And when we do so, we are then left with 0 is equals to a plus 3q, and that is their one equation. Then when we are looking at our second equation, we can do exactly what we did with the first equation, because we know that our asymptote will still be -2, which means there in the denominator we have x plus 2, and of course we have that plus a q over there. Now we cannot substitute that same point because it is going to lead us to the same equation. We can take the second point that we've been given, and that is where where y is a -1/2 and our x is a 0. So now substituting those two values, we are left with a -1/2 is equals to a over 2 plus a q. And again, just to avoid those fractions, because really there is a way of simplifying that equation, we can just multiply everything by 2, because if we want to get rid of a denominator, we multiply by the denominator. That is going to give us a -1 is equals to an a plus 2 q. And those are our two equations. There we have our equation 1, and of course there we have our equation 2. We need to simplify one of the equations so that we have an equation 3, and we can go ahead and simplify this equation here. We can say it's a negative a is equals to 3q, and of course because we want a variable to be alone and we want it to be positive, we are going to have a is equals to a negative 3q, and that can be now our third equation. And as you know, with simultaneous, we're going to take that simplified equation and we're going to substitute it into our second equation, because the simplified equation comes from the first equation. And of course, remember, you can choose whichever equation you want to simplify. It really is your choice. Now, taking that third equation, we're going to substitute it into our second equation. That means we are substituting the value of a. That is going to be negative 1 is equals to a negative 3q, because that is what a is equals to. That's going to be plus 2q. And because the q's there are like terms, that means we have a negative 1 is equals to a negative 3 plus a positive plus a 2q. That's going to be a negative 1q. And because negative 1 is equals to a negative q, we know that if we divide both sides by a negative 1, that is going to give us 1 is equals to q. And just to confirm, you can then go to the equation that has been given and look at where our horizontal asymptote is placed, because that q represents the horizontal asymptote. And look at where it is placed. Of course, we can see that the value of q, according to what we've been given, is 1. And according to what we've substituted in the place of the vertical asymptote, of course, we can see that we have an x plus 2 there at the bottom. That is just to confirm to yourself that you are going the right direction. Now, all we need is to find the value of a. And of course, from our three equations, we know that we can take the value of q and just substitute it into any of those three equations. So if we say a is equals to a negative 3q, just by substituting the value of our q there, which is 1, because we've calculated 1, we can see that our a is equals to a negative 3, and that is then the value of a. And if we look at our equation there, if we go and we substitute these values that we've calculated, we can see that our a is definitely a negative 3, and this of course is divided by x plus 2 from the vertical asymptote, and then we have a plus 1 from the horizontal asymptote. And your final answer should be the equation that was given to you. Notice how we didn't even use that equation at all, because when the question says show that, that means that that is supposed to be your final answer. Let's look at the next question under this hyperbola. It says there, write down the range of g. Now we know that the range is referring to the y values, and we know that when it comes to hyperbola, the y values are all the values that exist except for one value only, and that would be the asymptote. So we can say there that y is an element of real numbers except for the horizontal asymptote, which in this case is a positive 1. So y is an element of real numbers, but y cannot be a positive 1. And remember, when you are asked for the range or even the domain, you need to specify whether you are talking about the x values or the y values. So the range there is the y values. The last one there says, determine the equation of h, the excess of symmetry of g, in the form y is equals to mx plus c, where m is greater than 0. So the line of symmetry we know is y is equals to x plus c. And of course, we know that our gradient there is positive. So we are told that the gradient there is positive by them saying m is greater than 0. Then what do we substitute in the place of x and y? Yes, it is the asymptotes. You always substitute the asymptotes. Now, if you can remember our asymptotes, we've got x is equals to negative 2, and we've got y is equals to a positive 1. So in the place of y, we are going to put a positive 1. In the place of x, it's going to be a negative 2. And from this calculation, our value of c is 3, which means that our equation is equals to an x plus a 3. And that is the equation of the axis of symmetry. Let's go to an ad break quickly, and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson, where we are going to wrap up this lesson that we've been having on finding the equation of functions. So we were looking at finding the equations of the straight line, the parabola, the hyperbola, and of course the exponential function. Now, looking at the keywords that we were using during the lesson, of course, these are words that you are also familiar with, and those are function, x-intercept, y-intercept, turning point, maximum, minimum, asymptote, domain, range, and the axis of symmetry. So those are words that you are familiar with when you are working with functions. Now, looking at the common errors or the misconceptions that you might have when you are working with finding the equation, remember to always associate the function of a formula, or associate the formula to the function, and also the shape of the function. And remember, when it comes to the asymptote, do not get confused. You must know that where a graph does not touch, that of course is an asymptote. And of course, you should know the differences between an increasing and a decreasing functions. And of course, it's important for you to know the standard forms of each of these functions. And of course, always remember to leave an equation in standard form, so that when you are working with it, it is easier to recognize or easier to substitute those values. And of course, remember, you should always master how to interpret from the given information right to the standard form of an equation, so that you can find the equation of that function. Lastly, remember those skills that you always need to practice when you are at home or at school, so that in the exam you will be able to answer those questions. And lastly, the only way to do maths, or the only way to know maths, is of course to do maths. The more you practice, the more you'll be able to master these questions. And those are more question papers that you can use to practice. Thank you for joining us for this wonderful lesson. I hope to see you next time. Goodbye.